Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. Let's go see if we're actually streaming tonight. For some reason, I didn't get the countdown.
If you love the out...
There we go. Now it looks like it's coming together. I didn't see the countdown start, which is kind of weird. But right now, as you can see, we've got the moon in the background, so I'm going to go ahead and get rid of my face here and let you guys have a quick look at the moon. Now, tonight, we are using the Meade 10-inch Schmidt-Cassegrain telescope out in Shamrock Banks Observatory, out in the dome. Our camera this evening is a ZWO 6200 color one-shot camera. So this is actually a color image of the moon. Our mount is the CGXL, and we're not using any tracking. We're just using very short exposures for the moon itself because it's such a bright object. You know, we were talking about this a little bit earlier today. When you're using a telescope with an eyepiece, if you happen to look at the full moon through that without any filters on it, you'll actually have some pain in your eye because it's that bright. But, you know, it's nothing like the sun, of course, but it is pretty nasty. So, Judy, looks like we've got you on. I don't think we have anybody else in yet. Oh, we got 5 people watching. They just haven't checked in and said hi. So, if everybody would, do me a favor and just go ahead and check in, let me know you're here, and then we'll kind of start our little tour of the moon. Right now our focus is 2.85, which is really good, considering the focal length of this telescope at 2770 millimeters. So we should be able to get some pretty good views. As you see, even on full screen, we can't quite get the entire moon in. I want to make sure that we can see my cursor over here, so I'm going to give that a second just to check and see. Rodman, how you doing, my man? Welcome. Glad to have you here. We've got a really nice night to look at the moon. We should do this for probably an hour or so. Yep, looks like you've got my cursor over there with no problem at all. So we're going to have a look at the moon for an hour or so. Then I'm probably going to get a couple of images of Pluto, which is something that I'm going to do for a video that I have coming up. I want to reproduce the discovery of Planet X back in the 1930s. So I've got images of Pluto that I got with Dr. Parks back on August 30th. And we're going to compare it to what we see tonight. And we're going to see whether or not the position of what we think is Pluto switches. All right, so let's just have kind of a basic rundown of the moon. Now, a lot of people like to talk about the man in the moon, and that's fine. That's kind of common here in America, you know, North America, United States. A lot of other cultures have different names for the things that you see in the moon, and one of my favorite is the rabbit in the moon. Now, obviously, we're just past the half moon right now. We're at about 60%, so you can't see the whole thing. But here are the rabbit's ears. Here's his snout, and then he'll have a body over here, and then a little tail down at the bottom. And I like to do that because it helps me identify some of the different seas that you'll see. So for example, this is the Sea of Crisis up here, the round one. This is the Sea of Fertility, and below it is the Sea of Nectar. And this part right here, the dark area, this is the Sea of Tranquility. So here's one rabbit ear, here's the other rabbit ear, here's the top of his head, and his snout is the Sea of Serenity. So I remember snout, top, ears, and what he's thinking about. And rabbits are rather nervous Nellies, so we'll call that this. So we'll think that he's in crisis all the time. Now, if we come in a little bit, let me show you how I like to focus on the moon. So there's 33%, and we're going to bring it over a little bit. Now, these are 3 rather rather familiar craters. We've got Archimedes and we've got Autolycus, and I honestly don't remember the name of this last one for some reason. It always seems to elude me. But I want to draw your attention to this little dot right here. Now, this little object is a mountain on the moon that is about 1 mile high. Now we'll go up to 66%, and you can very clearly see that little mountain. And even at 100%, you can see it as well. That's called Mount Pinon. And like I said, it's about one mile high, about, just a little less than 2 kilometers, 1.5, 2 kilometers. But if you can spot this easily, and you can see these little craters here, that thing there is probably 3 to 5 kilometers wide. This little one right here is 2 to 3. You get up here to the crater Plato. This is about 100 kilometers from one end to the other along this long edge. Now, the other thing that's of note in this is these mountains right here. These are called the Lunar Alps. And right here, you can see the moon's Grand Canyon called the Alpine Valley. Now, I was looking at my book here a moment ago, and these are the lunar Caucasus right here, by the way. And as you look in this area right here, we zoom out a little bit. So, here's the Sea of Tranquility. Notice it's darker. That's because it's a darker basalt on it. This is the Sea of Serenity, and this is the Sea of Showers. Now, everybody wants to know where the Apollo landings were and whether or not we can see the little flag. Well, here's the Sea of Tranquility. And if you look down and see this little outcropping right here, the Apollo missions, or Apollo 11, landed about right here. So that's the approximate Apollo landing site. And even at 150%, as you can very clearly see, there's really nothing there that you can identify. So that just goes to show the limit of my resolution, and this is actually a pretty good view. The atmosphere is relatively calm tonight. But the minimum that I can see are like these little craters right up here. These are several kilometers wide, okay? I cannot see something that is 50 or 100 meters wide that would be down here where the Apollo landings took place. So I won't be able to see the the descent stage that's still on the moon, the flags, the experiments, the footprints, the lunar rovers. Any of that stuff is just well below my level of resolution. Now, the question becomes why is the image moving around like it is? Well, that's the effect of the atmosphere. Now, even with a relatively calm, cool atmosphere like we have tonight, you see that we're getting a little bit of shimmering, or it's scintillating light coming through those little tongues of wind up there. When you see the jet stream, you really see a ripple that goes from one side to the other of the screen. We've just got basically a pretty calm atmosphere, but there is still a little bit of upper atmospheric wind, and that's what we're seeing right now. And this, I think, is something that, people say that it looks watery when you look up in space. Well, it does, but it's not because there's water there, it's because of this wind. Now, the way that you take images of the moon, let me get this thing out of the way. Come on. Okay. So when you want to take images of the moon like you see in the papers, what they'll do is they'll get a nice wide angle shot of the moon, or they'll zoom in on one of these craters or something, and they'll take 10,000 images, very short images. And then they will look at the 25% of those images that are the clearest. It'll discard the other 75%, and it'll only stack that 25% best images. And then once you have that, you've got a pretty decent base image of the moon. And then you can actually sharpen it up a little bit using some software. I've done that a few times, but that's not kind of what we're doing tonight. But I just thought I'd point that out and tell you how they did that, because, you know, a lot of people wonder, how do you get nice sharp images of the moon from Earth if you've got all that shimmering in? Hi, Steve. Welcome to the show. Tonight we're looking at a 60% moon using our 10-inch Meade SCT. The camera's a ZWO 6200 color, so this is actually a color image of the moon. And our image here, when it's full size like this, here's the full size of the image. That's about 9,000 pixels wide, 9,500 pixels wide, and it's over 6,500 pixels deep. So we've got an awful lot of data coming in here to the computer, to the point that when I go to process these, especially if I'm using the black and white version of this camera, the ZWO 6200 monochrome or MM camera, the images are just so large. They're 122 megabytes a piece, and trying to stack those exceeds the memory capacity of my computer. Normally, you know, for a full run, I like to do 60 images. I simply don't have the computing power to do that. I can't do more than about 40 or 45, or else the computer just runs out of memory. And it's a pretty good computer, you know. So what would you guys like to know about? Oh, let's point out one more. I want to have a look here and see if I can see the landing site of Apollo 15. That's near Hadley Crater. And there's actually a rill right next to it. So we're going to come on over here. So now, looking at this area right here, Apollo 15 landed right here. Actually, I'm sorry, it's actually right there. So that's the landing site for Apollo 15. Let's go up to about 150% here. Now, what's interesting in this area is that so Apollo 15 is right above this little prominence right here. So let's take that out so we can get rid of it. Now, snaking through here is a rill, the Hadley Rill. This is a little, almost looks like a dry riverbed, but it's probably what they call a collapsed lava tube. And as you see, I just don't quite have the resolution to hit it. And I'm trying to find the Hadley crater in here. And I just don't think that we have enough resolution. It should be, that might be it right there. But as you see, it's just really at the limit of my resolution. I can't get any tighter than that. I would need a larger telescope with a lot more aperture to be able to get that level of detail. But that's the Apollo 15 landing site. Now, let's go back out here a little bit and just kind of give you the names of some of these places. All right. This is the Sea of Vapors right here. And there's a couple of smaller seas that, you know, everybody's familiar with, Tranquility, or even the Sea of Serenity, perhaps even the Ocean of Storms out in here. But there are some smaller seas out here. For example, this is the Humboldt Sea right here. Okay. This little spot right here by the Sea of Crisis. Right here is the Sea of Foam. And this is the Sea of Waves. Yeah. One thing that you'll notice about this as well, when you look at the moon, a lot of people think that the ideal time to look at the moon is when it's full. That's not really the case, because when it's full, the sun is essentially behind you and it's shining straight down into these craters. I just want you to have a rough look at the detail here. You see the detail here in the Southern Highlands? Look at all those nice craters down there. Now compare that to an area that's in direct sunlight out here on the eastern limb. Notice how you lose a lot of the detail. You can't really make out craters in this area. But when you come down to the Southern Highlands here, not only can you very clearly see the shadows at the rim of the craters, and the opposing side is sunlit, so it's very bright. You can actually see the central mountains in a lot of these craters. These Tycho-class craters have got a set of central mountains. Some craters don't have the mountains, and some of the larger ones do. And what this is caused by is as an asteroid or a large meteor hits the moon and blows out this hole in the moon, the shock wave goes towards the center of the moon in that direction. And then there's a rebound as it hits the rock below it and bounces back, and it forces up these central mountains. And if you look down on some of them, I'll see whether or not we can see Tycho tonight, but here's another central mountain. These don't have central mountains. This crater right here is called the Ptolemus. And it, as you see, does not have a central mountain, but the one just below it, Elpinosus, does have a very small central mountain. And I don't even want to try and pronounce this one here. Arzachel, I think is what they call it. So, the refractors, Judy, the refractors, or the reflectors that were put on the Apollo landing sites are actually on all of the Apollo landing sites. And they are all working right now. So we can still bounce things off of them. Tell me it is overkill without saying it's overkill. What, all of this? Think the images are too much there, Steve? I want to see whether or not we can go down and see Tycho at all. Not quite sure we've got it down far enough. Here's the terminator line of the moon. And as you see, it's just past half. Now Tycho is located down here. We're going to see if we can spot it real quick. Tycho's actually a pretty small crater. And that's it right there. That's Tycho right there, I'm pretty sure. Yeah, that's it. Now you see Tycho has a very large mountain in the center of it. And there are some telescopes that can resolve that mountain, and there's apparently a big freaking boulder right on top of the mountain. So these are the Southern Highlands, they call them down here. So this is Ptolemy, Alphonsus, Erzakel, with that little central mountain in it. Don't see what the name of this one is. Now, Copernicus is going to be out in here, so we're not going to be able to see Copernicus today. Let's go see if we've got some other interesting. Let's see. See, a lot of the craters that a lot of people are familiar with are still hidden behind the Terminator line out in this area here. Now, let's see if I can manipulate this just a little bit. See if we can see into that Terminator line at all. Now, that's dark as dark can be. I don't think I can get it any. I can't expose the stuff that's in shadow right now. I guess I could probably do a longer exposure. We could try that. So we're at 125th of a second. Let's bring it up to 4 seconds and see if we see anything on the side of the moon that's beyond the Terminator there. No, just too blown out. Astronomy is a patient science. You know, you've got to wait. You got to pick your battles, so to say. So if you want to see craters, you want to ideally have the crater just off the Terminator line. If you want to study a particular crater, you need enough magnification and enough resolution to see them. But basically, that's what we're looking at right now. Now here's an interesting thing. I think we can see that. Right here, this is the Sea of Dreams, or the Lake of Dreams. And next to it is the Lake of Death. So these are small mare or seas. And they're just called lakes because they are. And this, of course, is the frigid lake right here. Mare Frigoris. Now, let's go ahead and have a look at those mountains again real quick. Well, I'll tell you what, while I'm moving around a little bit, does anybody out in the audience have anything they want to have a quick look at or see? So here's Mount Pico again. These are the lunar Apennines down here, and these are the lunar Caucasus. And as I said a few minutes ago, out here by Plato, these are the lunar Alps. And down here, of course, we have Archimedes, Autolycus, And Australis is the name of this one. So this is Autolycus, and that is Australis, and that is Archimedes. Now, what are the sizes of these things? Autolycus is 40 kilometers wide. 83 kilometers for Archimedes. And Australis, this one right here, is 55 kilometers across. Now, if you look here, you can see some dark material radiating out. That is the ejecta from Australis. Yeah, the size of the files are pretty outrageous. Yeah, I meant on the moon, Judy. What time we got? We've been doing this about half an hour. So I figured I'd probably look around a little bit more for the next half hour or so, and then we'll probably do a shot of Pluto. Let's see where Pluto is right now. Dum dum dum. Here we go. So here's Jupiter, Saturn, and the moon. Let's go find out where Pluto is. Now, Pluto's kind of in a bad spot. Well, it's only going to get worse. Let me shoot over to Pluto real quick. And let's see if we can get a quick image of Pluto. That's getting ready to go into the trees is the only reason I want to do it right now. It might already be in the trees. But we're going to have a quick look. Yeah, just for laughs. We need about a 15-second image for Pluto. Let's go see what we come up with. All right. I may be in the trees. Let me go look at it real quick. Give me half a second. Yep, Pluto is no bueno tonight. It's already in the trees. There's no way we're going to be able to hit it. So we'll go back to the moon real quick. That's unfortunate. I'll have to get it early on another night. So the mount is actually linked to Stellarium, and I can pick a target on Stellarium and then slew the mount over to it. So let's go see if that worked. It's going to be washed out because we got to do a much shorter exposure. We were doing 15 seconds there. We want to do about 125th of a second. All right there. Let's go see what we got. There, we're a little happier there. Nice shot of the Southern Highlands. Focus, as you can see, is really good tonight. All right, so does anybody have anything on the moon that they want to see, or you want to go on to another target? Because we can always do that. We do have a couple of them close to us. So, for example, right here is Saturn. That's not very far away at all. Let's run over and have a quick look at Saturn. Let's go to about a quarter of a second, see what we got here. Boy, it's taking the long way, isn't it? Judy, thank you very much for that super chat earlier. That all goes towards the observatory and buys us new equipment and things. Everything in the observatory is pretty much funded by the viewers. That's one of the reasons that we got a couple of names on the observatory itself, including Judy. We've had cameras donated, had a lot of other electronic equipment donated. We've got some nice Patreons. I hope you all take a moment and maybe think about supporting the channel a little bit. We're only going to get better. Now, let's go see where we are. Well, there's Saturn, obviously. Right there. Now, what we're going to do is just kind of move this around a little bit. Kind of move it up a little bit more towards the center of the screen. Where'd it go? Ah, I lost the son of a gun. So, let's figure out where we are. Do a quick 8-second exposure. While we're doing that, we're going to go ahead and just double check this and see where we are. Yeah, we should still be on it. I wonder if it just popped behind the tree. Let's go over a little bit further away from the trees. I think it literally blinked out like that. It leads me to believe that it just went behind the tree. I know this guy's not behind the trees. He's right out in the east. Looks like we missed our opportunity for Saturn by just a few seconds there, because we had it just for a second and then it just disappeared on us. I think it got blocked. You know, the moon's getting into the trees right now, and the way the branches are, there's always one that sticks out someplace. And there is Jupiter. So, here we have Jupiter, and we have the 4 Galilean moons. Now, if you compare that to what it looks like in Stellarium for today's date and this hour, let's have a quick look. See what they're supposed to look like according to NASA there. One, 2, 3, and 4. Now, if you look at mine, you've got 1, 2, 3, and 4. It's just, I'm looking at it upside down is what's going on, and that's why they're reversed. But let's go ahead and see what we can do about maybe getting this centered up a little better. And then we'll try and get some banding or something on that planet and see if it shows up. See, the problem with bright objects like planets, you can either see the planet details or you can see the moons. You can't see them both. You can somewhat with your eyes because your eyes are a little bit more sensitive, but the cameras are kind of one or the other. Okay. So let's kind of drop our exposure down here a little bit. So you see we've lost the moons, but we're definitely getting a lot more detail in the planet. You can see the banding. Now our colors are off a little bit. Probably has to do with the fact it's such a short exposure. Let's go ahead and put these both back to 50% and then have it hit auto again and see if we can get a little better white balance. That's about the best that you can do. The equipment that I have is not designed to look at planets. For planets, you need very large apertures and very long focal lengths. Now, this is the biggest telescope that I have at 10 inches and 2770 millimeters of focal length. Now, commonly what they'll do is they'll put Barlows, which are kind of like magnifiers, between the telescope and the camera. So it'll double or triple the focal length. That, you know, for example, this is an f10 telescope, which has to do with the ratio between the focal length and the aperture. The problem is when you increase the aperture, you increase the f-stop on the camera and make it a much slower camera. So if I were to put a 2-time Barlow on this, I'd move my f10 scope to an f20 scope. And the only thing I could, you know, it would magnify the planet a little bit more. But I just, you know, it would take so long to get an image on it, you know, between the atmospheric shimmering and everything. I wouldn't get a good one. Now, to give you an idea of why this doesn't have a tremendous amount of details, that's the full-size image of Jupiter in my telescope at 2770. So it's still very small, and you're only dealing with a very tiny portion of the sensor on the camera. Now, my telescopes are designed more for wide-angle views. Yeah, Rodman, I finally got Nina working right. You know, I had some issues with the mount. That went back to Celestron, and it got a lot. And, you know, we got that fixed, so it doesn't seem to have any issues anymore. Got my cable management down to a science, but more importantly, using the Hotech Advanced SC collimator, I was able to get this telescope properly collimated, so now it really focuses well. So, as a matter of fact, we've been doing this for a while now, so it's probably a good time to go ahead and do a focus run. I'll show you how we do that. So, what I want to do is I want to go to an area here that's got some stars in it. Maybe not too many, you know, not like this, but, you know, has a group of medium stars in it. So what we'll do is we'll kind of go right here, for example. So let's go on over here. Okay. Now we've got that. Now what we're going to do is we're going to go turn the camera off on Sharp Cap. So let's turn this camera off. Then we're going to go over to Nina, and we're going to turn the camera there on. Just hit cooling while we're at it. And go down here to the camera. Now, what I'm going to do now is I'm going to do an autofocus run. So let's go ahead and start the autofocus run. So we're going to take a series of 6-second images, and it's going to move the robotic focuser every time we take an image. And over here, we're looking for a nice V-shaped curve. And at the bottom of that V, the minimum amount, that's your optimum focus. Now, the problem that you run into, hang on. Now, a problem that you run into when you're doing this, you know, during the night is that the temperatures change during the night. And, you know, the telescope starts out there during the day, and it's got a certain temperature that it that's the ambient temperature that it hits. Then when the sun goes down, the temperature starts dropping, but the telescope has to shed that heat. And as a result, it spends pretty much the rest of the evening cooling. You know, you get most of your cooling in the first hour, but after that, it still continues to cool. And that causes the mirror in the back of the telescope to contract. And as that mirror contracts, it pulls you a little bit out of focus. So ideally, when you're doing kind of formal imaging, you want to focus every 15 to 30 minutes. And that way there, you just keep that focus nice and tight. And that's what we're going to do right now. Ideally, we want to have the half-flex radius, which is the number that you're seeing in here. You know, like that's 3.4, 3.6, 3.7, 3.65, 3.7. That's called the half-flex radius, and that is a measure of how good your focus is. The smaller that number, the better. Now with the RASA, I can get 1.5 to 1.25. With the Ritchie Crayon, I get just under 2. However, this is related to the focal length of the telescope, and when you get a focal length like I have, I can't really get it much below 3. If I can get it down to 2.85, I'm actually pretty happy. This one here is not doing a very good job. So you see, I'm not getting a nice even curve. So I'm probably going to move to a slightly different location and redo it. See, I don't have too many stars here. So we'll probably go over to an area that's, you know, maybe by the Milky Way. You don't want a lot of nebulosity. You don't want super bright stars. And this isn't giving me a really good focus at all. So I'm going to go ahead and stop it. And I'm going to go to a better spot. Let's head on up here to Navi and see what that looks like. What you want is a nice even background of stars. So let's go see what it looks like up here. Oh, much better. Look at that. See that? Now, one thing I'm going to do is I'm going to go ahead and I'm going to move off of this really bright star because that tends to interfere with it a little bit. But that's a real good area for stars right there, it looks like. Come on. That's the Heart Nebula and that's the Soul Nebula, by the way. The other nice thing about this area is it's pretty high up in the sky. That'll give me a little better, less atmosphere to go through. So let's go see what this one looks like. There's the little star that we just zeroed in on, but you see we've got a nice range of stars around there. Have a quick look. Yeah, not bad. Let's go with that. So we'll stop taking images here. And we're going to start an autofocus, and I'll be right back. And no, I don't use the same stars all the time, Rodman. What I like to do is, you need a nice star field. It's actually kind of nice to get a star field near your target. Sometimes you'll actually focus right on the target. But I like to get a nice star field near the target, and then I'll also do a plate solve and use that to slew over to my final target. Man, this thing just does not want to do this tonight. It doesn't want to focus properly. Let's make sure my settings are good here. Star, parabolic. Thinking we might want to go to 8 here. That all looks pretty good. See how the stars are out of focus? Now, one thing you can tell though is the collimation is nice because those dark centers of the donuts there are right smack dab in the center. But that's definitely not giving me a good focus here. We might want to try that one more time. We'll see if this gives us a little better focus here, and then we might have just been too far out of range. Let's go ahead and get a quick image here. That's still quite a bit off, isn't it? Had a little issue with this a little earlier ago. Where it didn't really want to go into focus, and I managed to get it in just 20 minutes before we started this. See, that's a little better. See how the donuts are shrinking down? Now you see this speculation around the side of the star? This may be due to what's called lens pinch. Lens pinch. Which means that my collimation screws might be a little too tight. There, now you see that's a little more solid now. So we're going to kind of go from here. And we're going to try another autofocus run real quick. See if we can get a little better. So when I take this telescope off and bring it in the house, no, it's not weather. The weather's perfect. When I take this telescope off the mount and replace it with probably the Ritchie-Chrétien, which I've been doing some work on, I need to go test that out and test out its collimation. I'll bring that in. I'm going to do a couple of things to this telescope. First, I'm going to put a focal reducer on it, and second, I'm going to loosen up the screws on the collimation of the secondary mirror, the 3 screws out there on the secondary mirror. And I'm going to see whether or not I can loosen those up enough that I get rid of that pinched optic look. You know, typically what I do with the observatory is I rotate out the telescopes. Right now the RAS is here in the house with me. It's in really good shape, but that's a wide field telescope looking for asteroids and such, and looking at large nebula, although it's not good for nebula because it has the black and white camera on it. It's more for measuring asteroid orbits. The Ritchie-Chrétien, well, the Schmidt-Cassegrain is a high focal length telescope. The RASA is 620 millimeters. The Ritchie-Chrétien is almost 5 times that, 4.5 times that. And it's got a lot more magnification, so it's nice for looking at really small objects like galaxies and even planets sometimes. With the focal reducer on it, I'll make it a faster scope. I'll move it from an f10 scope down to about an f7 scope. And we're going to see whether or not maybe that improves my focus values and my asteroid detection. Yeah, you see that's 3.6. Now, even though it doesn't look bad, you know, those stars are small and round. That's off a little bit, but it's also way up here. Let's go see what it looks like when it's done doing the focusing routine, because right here would be where the focus would be, right in this area. There's a small dot right there. That's where it's going to try and focus this thing. So let's see what that is. 2600 or 260, 260,000. There we go. I knew I could get it out. So let's go ahead and just put it there. The focus routine is not having a good night. So we're just going to kind of manually put it on 260,000 steps. And there we are. Let's go see what it looks like. Let it take a quick image. Well, they're solid and they're round. Could be better. Could be worse. All right, Judy had some requests a little earlier. M94 or M106. Let's go ahead and see where they are. That'll be a big no, Judy, on M94. That'll be a big no, Judy. They're too low on my horizon. Ah, I made a mistake there. Let's try that one more time. M100. Oh, it's only one off. Let's try that. That'll work. So here is Ursa Major, the Big Dipper, or the Cleaver they call it in the UK. And there's our telescope coming in. Let's go see if we can figure out where we are. Down here is where you see the image being taken. No, I don't see too much out there. There's a few stars. Let's make sure that the... I haven't installed the camera out there yet. I've got one now, and I'm going to probably install it this week. But until then, I've got to go out and actually look at the alignment of the shutter with the camera or with the telescope. So let me go make sure that we're getting all of our aperture there. Well, you get a few more stars when you have more than 2 inches of the telescope sticking out of the dome. So let's try her again. So you got a few more stars there. And we have a location. So you see down here, it's re-slewing to the target. Now it's doing another exposure to make sure we've got it. So let's go see what this looks like. This is M101, the Pinwheel Galaxy, the one that has that supernova in it. Okay, so thing ought to be right in the very center right here. Now, here's what I'm going to do. I'm going to turn off the camera here, and I'm going to turn it on back here in Sharp Cap. Now, the reason that I'm going to do that is that I want to do what's called live stacking. So, we've got what we need here. Quick 4-second image. Now, while that's looking around, so there's the galaxy right there. This is on the guide scope. So we're going to start guiding off of that star right there. You know, the small telescope can see it. Now what we're going to do is we're going to go ahead and start a 3-minute image. And while that's cooking, we're going to go ahead and mark that up. So this is going to be M101. Gonna remove the stretch from all of these histograms, and we're just going to go ahead and let this go, and it'll just start cooking along. So this is a good time if you have, we've got 11 people in the chat right now. We got a few people that need to introduce themselves. Say hi, folks. And let's go see what you want to do. We'll probably get a few images of M101 right now. Have a look at that supernova. And then I think we're going to try and track down a few comets, if you guys are game for that. And that'll be what I'll be doing for the rest of the evening. I have good weather until at least 2 a.m. It's 10 o'clock now, so I've got enough for at least 2 full sessions looking for comets and asteroids. They take about 2 hours each. And then I'm going to pack it up. So what do we have here? Well, folks, don't be shy. Come on in and say hi. You got 10 people watching. We've only had a chat with a couple of them. Now, if you look down here in the corner, you'll see the progress on our image. So we're about, looks like we're about 1 minute and 34 seconds into this image, and it's going to be a total of 3 minutes. So we've got 1 minute and 20 seconds to go. Hi, Colin. Welcome aboard. Where are you from, my friend? Where is everybody from, by the way? I know where Judy's from. She's from Finland. Okay, so you're up by Vancouver. And Colin, you're in London, the home of the Greenwich Observatory, right down the river from you. I actually ordered a book from the Greenwich Observatory on the, it's called Longitude. Yeah, British Columbia. All right, so we're going to have an image coming out here soon. Now, the way you do this is you don't stretch your image here. You stretch your image down here. Okay, so here's our data. Now what we're going to do first, you see how we've got a red, a blue, and a green curve here? If we click that, that brings them all together, and that does what's called white balancing. Now the next thing that we need to do is our data is here, but this is what the data is what the camera is reading. So what we want to do is we want to concentrate on where the data itself is. And the black line should be right here at the peak. You know what? I've got dust motes in here. So we need to put our, and I also have a lot of vignetting, as you can see. So what I need to do is I need to put in my, my flat frame. But here is the Pinwheel Galaxy. And if we make that a little bit bigger, so let's go see where we are here. A little wider. That right there, that red dot is the supernova. Now that was discovered in mid-May by a Japanese amateur astronomer, very much like me, except the Japanese version of me. He had a 60-centimeter telescope on a mountain up in Japan, and he was taking a picture of this, and lo and behold, there was a dot there that wasn't there before. So what I'm going to do is I'm actually going to get rid of this image. Probably in about 15 seconds I'm going to dump it, and then we'll get ready to get the next image. Come on, dump. There we go. There we go. So now when this next image comes out, we'll have a flat frame in there. Let's see if we get a little better quality image, and those are the ones that we'll stack. About 5 seconds to go. You're 350 miles north of Vancouver, huh? You're up by there. Now you see, look, all the dust bunnies are gone. And you can very clearly see that supernova. But let's see what this looks like full frame. Come on. All right, so I've got some reverse vignetting out here, but the dust bunnies are a lot better now. And if we just kind of bring that up a little bit like so, I'm getting a lot better image of this galaxy. Then we'll hit auto hide on this. Well, before we do that, okay. So there's the Pinwheel Galaxy. This ring right here is an artifact. But of note, our stars are nice and round. See how nice and round those stars are? So we're getting excellent tracking. And if you want to look at the guiding, we can come over here. And our guiding is below 1/2 arc second. So the mount tracks things on its own. And that gives you the ability to take up to probably 30 to 60 second exposures before you start getting any streaking at all of the stars. When you're taking longer exposures than that, you use something called guiding. And that's what this program, PhD2, does. So this is a small telescope that's on top of my telescope. It looks like what a lot of people refer to as a finder scope, but it's actually called a guide scope. And what it does is it takes a picture of the star field in more or less the same direction that the telescope is looking at. And you identify a star like this one right here, and it'll lock onto that star, and it'll use these other circled stars as references. And anytime that star starts to move out of those crosshairs, it'll fire a command off to the mount to bring it right back to the crosshairs where it belongs. And as a result of that, you can get 3 to 5 minute exposures all day long without any star streaking. We're taking 3-minute exposures right now, and the stars are all nice and round. Joe Whipp, our Antarctic explorer. How have you been doing, Joe? How are things doing in Philly? It must be getting close to season. Are you going to Antarctica this year? Now you notice when we first took this, there was a lot, you see all this graininess that's out here? This is called noise, and even though it's a cooled camera, let's make sure the cooler's on. Yeah, the cooler's on. The camera sensor is being cooled to -20°C, but even with that, there's a lot of noise in the camera, and that's what this graininess is. Now, the way you get rid of that is this graininess changes from image to image. So what you do is you take a series of images and stack them on top of each other. You line up the stars, and you just, kind of like if they were on transparencies, and you took 20 transparencies of 20 different images, and then you lined up all of the stars. This stuff here will start going away. So we'll probably take about 15 minutes worth of images here. You can already see the supernova right there that's red, and that's considerably dimmer than it was when I first saw it back at the end of May. It was discovered in mid-May. I put my telescope on it at the end of May, and it was pretty neat. Well, Michigan State triumphed last night against our arch rivals, the University of Michigan. My mom called me up in the middle of the night to ask me if I wanted to talk about the game. She, of course, is a University of Michigan graduate. My wife and I are Michigan State graduates. Apparently, we had our asses handed to us 49-0, which is quite the rarity, but it did happen. So I'm officially in mourning, but I'll get over it. Now, if you looked at this star back at the end of May or early June, it was considerably, it was probably about that big right there, as big as the galactic core, only it was out here. That wasn't there 6 months ago. You know, that was something that he literally just basically saw it as it happened, because what he does is he goes from galaxy to galaxy looking for supernovas, like I look for asteroids. And he had swept through this area not long before, and then, 2 weeks later he comes back, and lo and behold, there's a supernova there. Yeah, it was a first-rate ass-kicking. But my mom was good. She's still laughing. Not with me, but at me. She's good that way. But they say that you're known by your enemies. So if we if we were going to get hammered like that, it might as well be by a good team like U of M. Now, as this stacks, see, we've got 3 images going now. But as this stacks, you're going to notice that this grain will get finer and finer, and then it'll go to kind of a uniform black. So, for example, here's 45 stacked images. And if you look at it, now, you see these 3 stars right here? They form kind of a triangle. This is a picture from August 30th. And I'm pretty sure that that little dot right there is Pluto. Because as I recall, it was just to the left and about that far below, down here, and off to the side. So Pluto was right in this area right here. Not 100% sure which one it is, but I was able to plate solve this image and identify Pluto. So what I'm going to do is I'm going to take another image like this, and I'm going to try and line up these stars. You see, you got the 3 here, and then you've got this one out here. Those look like pretty good ones to line up, and I know which stars those are. And I'm going to take another image, and Pluto should be down in this area by then. So it's kind of been moving in this direction. And it's almost, well, September, October. It's been 2 months. It'll be 2 months on the 30th. So that should give me a pretty good difference between the two. But you see how the back is kind of much more of a uniform color? See, you don't see that graininess. The stars are small and round. That's what we want to get. And it's starting to come out now. Now, mind you, I'm not an astrophotographer. I measure these little dots and just say, okay, well, I need to know the exact location where that is, At this particular moment, that's the dot, and I'll give you the right ascension and the declination of that dot. And then 15 seconds later, I'll repeat it. Or a couple minutes later, I'll repeat it. And that'll tell me, you know, I do that 3 times, and I can calculate the orbit of the asteroid. Yeah, those flats aren't as good as I'd like them to be, but they're certainly better than nothing. Those are called calibration images, by the way. No, there's no lens hood. There's no lens hood on this. There's a dew strap on it. Wonder why the dew heater wasn't on. That's weird. So let's get the dew heater on there. But that gives you kind of the idea of what the dew heater's doing right now. So the 12-volt output is powering my camera, and the dew heater here is warming up the lens to keep dew from forming on it. That may be an issue that I'm running into right now. Maybe I've got a little dew on there too. See how many images we have. Now, to fully get rid of that graininess, you need to have between 35 and 60 images. I think we're going to kind of call it a day here at 5, maybe 6. But while we're doing that, I'm going to go ahead and go on over here and go to the Minor Planet Center. We're going to see if we can get us some comets tonight. Okay, what do we have here? All right. So let's stop that. So I've put in the location of a comet called 71P Clark. And what we're going to do is we're going to move over to it. And while it does that, let's go see where it's going. Best turn off guiding as well. I don't know if I like that all that much because it's kind of low on the horizon. Let me see what we got here. That's just under 20 degrees above the horizon. That may not be a good target, but we're going to find out. Let's have a quick look at it. All right, so I can see stars here. They look pretty good. So it just plate solved and it found out it wasn't quite looking exactly where we wanted it, which is going to be right there. That might be it, you never know. This is a magnitude 17, no, excuse me. This is a magnitude 17.7 comet. So it's going to be a little difficult to see. We're going to definitely need to do some longer exposures on it. So let's go ahead and do that. Let's do a 3-minute exposure. Probably do about 30 of these. Get this all reset. Come on. There we go. I knew you could do it. So we're going to let this bad boy run, see what happens with it. Again, good time now to go back to the chat and see what we've got cooking there. No, they don't. Okay, so Colin, no, they don't all appear red. This turned red over time. It was originally quite white. Yeah, this is Sharp Cap. I'm actually quite pleased with it. It's one of my favorite, one of my favorite applications. I have Sharp Cap Pro, which runs me all of $15 a year. It plate solves, it resyncs, it live stacks. It does have a focusing function on it. It also has a sequencer on it. But I generally use Nina for the stuff that I sequence. Nina has a much better focuser on it. So it just seems to work a little better for me. So we'll give that about 45 more seconds. Now, the cool thing about comets when you do live stacking, now with Nina, what it does is it just takes a picture and then it takes another picture and then another picture and another picture and so on and so forth. But it doesn't stack them. It just keeps them in a file, and then the software that I use to look for the asteroids and comets and such stacks them. But when you do a live stack, it'll line up all of the stars, and what'll happen is if you have a moving object like a comet, it'll actually start forming a streak. So it makes it really easy to identify whether or not you nailed it. You got it. Now with this setup that I have right now, I generally, I can do magnitude 20.1. And we're going to see whether or not we got it. So the first thing that we're going to do is we're going to white balance it. Now the dark level should be pretty much right at the peak or even just a little bit towards the front of it. The mid level should hit more or less, cause the curve to hit more or less where the slope changes. All right. So this is our star field. Now, our stars are looking pretty good here. None of these really look all that cometary to me. I'll tell you what, rather than spend a lot of time on this right now, what I'm going to do is I'm going to turn this camera off. I'm going to do a quick refocus with Nina. And I'm going to see if I can get a little more solid focus in here. It doesn't look too bad, but I think it could be a lot better. And that looks like a nice spot of the sky to focus. So that's what I'm going to do. No sense in rushing things. Do them right the first time. It actually saves time in the end. I suppose I probably ought to put the guiding back on. While we're at it, I'm also going to check and make sure that the shutter is lined up right too. Because see how this has got kind of some white on it? That leads me to believe I'm clipping the edge of the shutter. Well, it wasn't bad, but I just kind of centered it up a little bit better. Just because I wanted to. See, that's already better. You know, it's almost 3.3, but still, I'm not all that unhappy with it. It's better than it was. I better go plug this thing in. Okay, lovely. Just a second here. Have this ready in a minute. There we go. That's a little bit better. Okay, now we'll just let it run for a few minutes. See, I'd rather use 2-minute images instead of 3, but I just can't do anything with that, you know? All right, we'll let that run for a couple minutes. Once we get a nice view of the comet, I'm going to go ahead and shut this down, and I'll continue it over on Discord, but I think this is long enough for one evening. Okay, so what I did here was I loaded this into Tycho Tracker, and here is one of my images that I just took. And what I did was I debayered this, so I converted it from a color image to a black and white image, and then I plate solved it, and then I looked to see what actual objects were in this frame, and it's identified a number of them. Most of them, these 20, 21, 26 magnitude things, I can't see any of that stuff. But this one right here, I sure can. And there's the asteroid. And if you zoom in on it a little bit, there's an asteroid right there. So, I don't see, there's where the comet's supposed to be. And I don't see anything there. But we'll see what the stacked images show. But that was just kind of a quick thing that I looked at just to see whether or not maybe I got it. But I'm still thinking that's a comet right there. But we'll see. So we've got 12 minutes worth of images. Still pretty round, but I think that's a comet right there. But we'll see. Yeah, you should have heard that. Yeah, that's definitely looking like a comet to me. I'm pretty sure that's a comet right there. Steve, you take care, my friend. Thanks for stopping by. You know, that looks like a comet, but that's one streaking. I wonder if that might be an asteroid. Miss Judy, good night. Thank you for stopping by. I'm just going to let this thing run for another 15 or 20 minutes. Let's go see what we get. We'll have our answer pretty soon because that one's streaking, but it's pretty solid. You know, that strikes me more as an asteroid than anything else. That's what looks like a comet to me. So this is the fun part of what I do. You just look at the same picture again and again and again and again. And when you get about 40 of them together, you run them through the software and it looks for anything in it that moves. Like I said, I'm pretty sure that's going to turn out to be an asteroid. Whether that's a comet, it should be right here, and I don't see it. That could be a distant galaxy, same thing with that one up there. But that one there looks a little fuzzier to me than anything else on that picture. See, that doesn't really look like the other stars. The other stars are nice and round and well defined. That's kind of fuzzy. I think that's a comet. Sometimes all you see is a dot with a halo around it like that because the comet's coming towards us and the tail is spreading out behind us. You don't always see a nice left to right tail. Could be coming to us or it could be going away from us. But in any event, the tail would be behind it because we're looking out and the sun is behind us.